Welcome students. Today we are starting a new topic, that is turning effect of force. We will understand what the turning effect of the force is. So starting from the first topic, that is basically in this chapter we will study, most of the time we will focus with the turning effect of the force. Uh, During daily life you have seen so many number of experiments, number of examples where we have observed the turning effect. Either we are opening the door, we are opening the fridge, refrigerator, or you are playing, you are using different types of things. So there are thousands of other examples in our life where turning effect of the force is applied. So we will go in detail to understand what is the turning effect and on what the factor this turning effect of a body depends. So let's start. Topics to be studied are addition of vectors, trigonometry, resolution of vectors, rectangular components, moment of force, equilibrium, stability of the object according to the center of mass, parallel and unlike parallel forces, center of mass and center of gravity. Couple. So here it is. Lecture number 1, or lesson 1 of this chapter. So let's start about the forces. A force can be defined as any push or pull exerted on a body. We have already discussed it. Force tries to stop, stops or tries to stop a moving object, or it produces motion or tries to produce motion in the body at rest. This was the concept of the force. What's the unit of force? That is Newton. 1 Newton is the force required to produce in a mass of 1 kilogram an acceleration of 1 meter per second. So 1 meter per second is square. This is the unit of basically unit of acceleration is meter per second is square, 2 times per second. So this is the concept of force. First we have defined force, then we have defined its unit. By considering a force, the following must be known. What? The magnitude of the force, the direction in which the force is applied, the point at which the force is applied. These are the three main key points which you have to understand, which you have to keep in your mind while learning the next topics of this chapter. One is magnitude of the force. You must understand what the magnitude of the force is. Weaker or stronger force, what will be the effect if the force is weaker, and what will be the effect if the force is stronger. Then the direction in which the force is applied, in which it plays a very much important role, because the rotation of the body also depends on the direction of the applied force, the point at which this force is applied. This depends. Rotation of a body depends on where, at what point you are applying a force for the rotation. So with the help of basic concept and with the help of mathematics, we will discuss in detail where these are applicable and where we need to take care whenever we are applying such types of basic concepts, or the uh, basic concept of for the rotation of any object. So here it is. What's the force? Push or pull of the body, which can change state of motion of an object. It may change the state of an object. Forces are vector and can be added by considering both direction and magnitude. Whenever there are vectors, we need to add these vectors by keeping in mind direction and magnitude as well. You can't change direction by your own wish or will. You can't add vector quantities like mathematical or arithmetical quantities, which you have already done during the previous classes. Now you are in a higher class. You have to consider the vectors and the scalar quantities while adding. Now, as a unit of force is in Newton, example of forces include friction, weight, air resistance, and also tension is also included in forces. These are the vector and can be added by considering both direction and magnitude. So here it is. Forces acting on a body. Here it is 2 Newton force. Here it is 6 Newton force. What will be the net force? Net force is because you are adding these two, and while adding, you have to subtract due to different directions. 6 minus 2, that is 4 Newton. And when both the forces and where the body will be moving in the direction of the larger magnitude force, that is 6. So with after taking the difference, finding the difference with the 4 Newton force, net force, this body will be moving to the other side of the larger force. Now, look at another example that is 4 Newton to the left, 4 Newton to the right side. If you are asked to find out the resultant force, there will be no resultant force. Sum will be 0, and the body will be at its own place before and after application of the force. Now, if you look at if you look at another example that is 6 Newton and 4 Newton, both forces are acting along the same direction. Then you will add these two forces and the resultant you will be getting 10 Newton. So let's consider fourth example that is if two forces 4 Newton and 6 and 4 Newton are acting to my left side or your left side and 3 Newton is acting to the other side, then you add up these two forces acting along the same direction. 6 plus 4, 10 Newton. Here it is 3 Newton. Find out the difference of these two. That will be 10 minus 3. It is 7 Newton. And the body will be moving along the direction of the larger force. So if you look at these examples, it clearly shows that we are adding these two vectors are the forces. So if they have the same direction, and we subtract if they have the different direction. And what will be the resultant if the forces are of the same magnitude acting along the different direction? And what will be the effect when both the forces are acting along the same direction and when both forces are acting in opposite direction? And if are the same, but if two direct forces are acting in opposite direction, but they have a difference of magnitude, then the body will be moving in the direction of the force which is of the larger magnitude. If one side elephant is pulling any object, other side a single person is pulling, then of course the result will be clear. The elephant will carry out because the magnitude of the force in the direction of elephant is more. So this is the reason. So let's see addition of vectors, how the vector quantities are added. Two or more than two vectors are graphically added by head-to-tail rule. This rule states that draw the first vector, connect the first vector head and the second vector tail, connect the second vector head and the third vector tail, and so on. At last, connect the first vector tail and the last vector tail. This is the resultant vector. You can also write in your own language that is much more simpler. This is graphical method of vector addition in which head of the first vector is joined with the tail of the second vector, or tail of the third vector is joined with the head of the second vector, and so on. Finally, a vector is drawn whose tail is with the tail of the first and head with the head of the last. This vector is called resultant vector. So this is the basic. It is also correct, but you can follow the easier one. I will show the figure. Here it is. Here it is. Look, this one is first vector. Head of first vector is joined with the tail of the second vector. And finally, a vector is drawn whose tail is with the tail of the first and head with the head of the last. This vector is called a resultant vector. This vector is basically resultant vector. So here it is vector A, here it is vector B. They have the different direction. You are asked to add these vectors. And how will you add these two vectors? You are adding like this. R, this one. AR is equal to A plus B. Here it is A, here it is B. Then you will add these two, A vector A and this one is vector B. You add these two vector, that will be R. Resultant vector AR, that is equal to A plus B. This vector is called resultant vector. It is defined as, you can note it down, it is a vector whose effect is equal to the combined effect of both the vectors added. Basically, this resultant vector is the result of the combined effect of these two vectors which are added together. So here is another example. If you look at, one force is acting in this direction, that is of 800 Newton. Here it is 300 Newton, which is acting in opposite direction. So the car will move. If you find out the difference of these two vectors, then it will be like 800 minus 300. Then it will be 500. This car will be moving in the direction of, towards the direction of 800 or larger force magnitude within with a force that is 500 Newton. This was the example, and then you have seen this one. So moving ahead, work out the answer. What will be answer? I have already told you, that is 500 Newton. So addition of vectors. How large must the force X on the body force 911 be such that the resultant force on the car is 0? Look, here it is 800 Newton, here it is 300 Newton. Then what should be the amount of force acting at point X? Add these two, that is 300, add a figure to make it 800, that is 500. So it will become a 0 force, resultant force will be 0. Why? Because this direction is rightward, other other one is leftward. If you find the difference, that must be equal to 0. So here it is. When resultant force is 0, the forces must balance out, and that is this is the formula. One side, X plus 300 Newton, that is 800 Newton. So find out the difference between the two. 800 minus 300 Newton, you are getting 500 Newton to the left side. It means if you introduce another 500 Newton force in the direction, along the same direction as a 300 Newton is applied, then if you find the sum of forces to the right and sum of the forces to the left side, as a result, you will be getting 0 resultant. So this is the reason to find out the resultant force. You have added these two vectors together. So here it is. If you look at this is another example. 3 Newton force is acting in this direction, 4 Newton force is acting in this direction, 7 Newton force is acting. So when this is a case when all the forces are acting along the same direction, that forces are called linear forces. If these are vectors, that vectors are called linear vectors. So in this condition, we add the magnitudes of all the vectors together. Say this is 3 Newton, this one is 4 Newton. We will add these two. We will be getting a figure of 7 Newton. And finally, we will draw a vector which is having the same direction as the direction of these two vectors which are added. And its magnitude will be equal to the sum of magnitudes of both the vectors added. Mean its magnitude will be 7 Newton. So here is another example. If there is 3 Newton and 4 Newton is acting to the opposite side, exactly opposite. So we will find the difference of these two because they are in opposite side. It will be 1 Newton. But if there is 4 Newton, here it is 3 Newton, then here it is 5 Newton. We will add these two. We will find out the third one. So here it is. When two or more forces are acting on a body, their combined effect can be represented by one force, which will have the same effect as the combined component forces. So this is the component forces. These are the components which we have seen during the head and tail rule, the resultant one. Such a force is referred to as the resultant force. The process of finding it is called the resolution of component forces. This is the, if this one vector is making an angle between the two, you will resolve it into x and y component. Finally, you will be able to find out the resultant force. So here it is, another step, that is branch of trigonometry. Very interesting, very much important to understand. This is basically branch of mathematics with the help of which we can calculate the sides and triangles of a right angle triangle. This is the main concept of trigonometry. Means it is a right angle triangle, and by using this right angle triangle, what we do, we can calculate the sides and angles of a right angle triangle. So if you look at, this is a triangle, this one is origin, this one is A, this one is B, this side is called hypotenuse, this side is called perpendicular, this one is called base, and in the triangle angle, this one angle is basically smaller than less than 90, but this one angle is 90. At angle A, this one will be 90, but these angles are less than 90. So what will be there then? Here it is. We will calculate three types of ratios of the angles: sine theta, cosine theta, cos theta, or tangent theta. There is a word used in English normally. People use different types of sentences to make it easier to remember, because so many times frequently these ratios are used and person has to quickly respond quickly answer these, that cosine theta is equal to base divided by hypotenuse, and tangent theta is equal to uh, perpendicular divided by base. So these are the ratios to remember. It is, remember, like people have made some their own sentence, that is, some people have brown hair, tightly packed, bound. So this is basically a technique used to understand. There are during different languages have used different uh, sentences to remember the trigonometry ratio, but simply you have to understand this is perpendicular divided by hypotenuse, cosine theta is base over hypotenuse, and tangent theta is equal to perpendicular divided by base. So if you look at the triangle at the back, which we have already done, it is equal to this one. So if you find the ratios, values of these angles, the values of this one, sine theta have the value that is 0 degree have 0, 30 degree have zero point 0.5. Similarly, cos 0 is 1 and cos 30 is 0.66. Again, you have to remember this table so that in future you need to understand what are the values of man uses of 45 degree, 60 and 90. At least these values of angle are frequently used during a course of study. So with this, our class has will be closed. So let's see again. So this is trigonometry, and trigonometry is basically used to calculate the sides and angles of a triangle. And then we have seen that these are the sides of a triangle, and these are the angles of this triangle. By keeping in mind this triangle, we have calculated the sides or the ratios of the sides. The ratio between perpendicular and hypotenuse is sine theta, base divided by hypotenuse is cosine theta, Perpendicular divided by base is tangent theta. You can use of your own language different types of sentences to make it easier. Like some people have curly brown hairs. So this is one technique to remember these two. So it will be more easier for you. Some S, people P, have hypotenuse, curly C, brown B, hypotenuse. So these are some of the techniques to understand to remember it. Then we have discussed the different values of angle which are already taken and you have to memorize. You have to remember these values frequently used in the course of your study. So at the end, I thank you all for your patience. Hope you people have understood during this class, especially trigonometry and addition of forces.